Hi and Assalamualaikum. My name is NORZARI bin NORZARI. My metric number is CE190166.
Assalamualaikum warahmatullahi wabarakatuh. My name is NURSALWA FARAHANI binti MOHAMMAD. Metric number CE190163.
Hi, Assalamualaikum. My name is ADLI bin NASIR, CE190156.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad SYAZWAN NOORDIN. My metric number CE190243.
Okay, for the introduction, a cache is a space for temporary file that make a device, browser or apps run faster and more efficiently. After opening an app or website for the first time, a cache stashes file, image and other pertinent data on your device for save as a temporary file. So, cache data is used to quickly load an app or website for every subsequent visit. Cache is distinguished by several factors, including their size, substitution block size, algorithm, and degree of associativity. Furthermore, cache also have two situations to improve the performance, which is where it can be hit rate or miss rate. Hit rate is whenever the processor wants to fetch the data from the main memory, first it will look up at the cache buffer to see whether the corresponding address is present in the buffer. If it is there, it will perform the operation by using the cache, so it's no need to fetch from the main memory. Meanwhile, miss rate is if the address is not present in the cache, it is called cache miss. If a cache miss has occurred, that does mean the processor has go to the main memory to fetch the address, and it take more time to fetch the data. So, to improve the direct map cache performance, we compare value of cache size in two situations to see whether it is hit rate or miss rate. Next, analysis of the literature. Since the early development of computer systems, there has been a growing need for faster and more powerful computer systems. This motivated the researcher in the area of hardware and software development of computer systems. Hierarchical memory structures are implemented to alleviate the impact of gap between speed of CPU and performance of main memory. Misses in caches can be classified into three types of miss, such as compulsory, capacity, and conflict. The compulsory miss occur when the block must be read from memory regardless of the cache design. Capacity misses occur when the cache is too small to hold all the concurrently used data, and the conflict misses are caused when the address mapped to the same address set. And in cache performance model, there is terms hit and miss rate. Cost of hit and the miss penalty. We are focusing on miss rate because we can reduce the miss rate. There are three ways to reducing direct map cache miss rate: by changing the capacity, change the block size, and using AND or associativity. In this experiment, we will reducing the miss rate by changing cache parameter that can be affected one or more cache. In fact, increasing cache capacity can reduce conflict and capacity miss rate. Meanwhile, to reduce the compulsory miss rate, we can increase the block size. This will reduce compulsory misses.
Okay, so we're gonna proceed on methodology. For our project title, Enhancing Direct Map Package Performance using Parakeet as the simulator. This simulator is very helpful to better understand its basic on the memory management concept. Use direct mapping and random address instruction to test the performance as example as shown here. Students are introduced to the reconfigurable cache architecture while refreshing their knowledge on computer architecture issues like logic design and register transfer level and computer system level architecture. This is the diagram shows the implementation of direct method cache. So in this project, what we do for direct method is based on this diagram. These are the 4 steps that we use to implement the direct method cache. Okay, so this is the flowchart. First start and then consider a main memory and cache memory value. 2048 bits for the main memory and 8 bits for the cache memory. Fill in the value of cache size, memory size, offset, bits, and instruction. These are the value of this, and this is the calculated value that being calculated in the Parakeet. Next, generate the statistic of hit rate and miss rate and submit the previous instruction. Proceed to memory request generated by the multiplexer. Set of number are read by multiplexer using select lines in parallel. From the multiplexer, the size of memory block, offset bits, and cache is being compared by the comparator. Okay, it's tag index and offset in peer cache. Okay, it's gonna divide into two, which is cache hit and cache miss. If it is yes, it is cache hit. If it is no, it is cache miss. Okay, cache hit, the instruction will be convert from hex to binary and allocate to tag index and offset respectively. The requested index will be searched in cache memory. For the cache miss, comparing whether the requested tag and tag in cache table same or not, and then both of it will go to register or replace in the cache table. This is the cache table that we been done in the Parakeet Simulator. Okay, and then it goes to NN. That's all from me.
Hi, so we continue to simulation part, which is we use the Parakeet Simulator. So I will show to determine the hit rate and miss rate and show how to use this simulator. So from the top here, we can see cache size, memory size, and offset bits. Sorry. So we can change the cache size here. So I use my value to for example. So press the submit. So you can see here, offset is 2 bit, index bit is 3, instruction length is 11, block is 9 bit. So next we assume our own instruction. So let's say I use 4, 8, and 5. So press the submit. So first instruction is 4. So firstly this is a hexa. So it transfer here to be a binary, convert into binary. So you can see here the index is 3 bit. So first index we request to search in cache table here. You can see here table. So here you can see the comparator here to compare which is the text same or not with the requested instruction. So you can see here text here is nothing number yet. So it will replace the text here from the instruction. So we can see it replace. So next 8, instruction 8, load 8, sorry, next submit. So it transfer here to binary, convert to binary. So it find the bit here. So it instruction load 8 also miss cache because you can see here there are no tag yet, so it will replace here. So next is 5. So 5 also will convert into binary. So it find the row number 1, index 1 here, and it will compare between this tag and this tag here. You can see here it's same, so this cache is hit rate, so it compare here, so it will cache hit or hit rate. So it also transfer the numbers, the binary text. So after we successful, you look to all the instruction, so it will show the statistic here. You can observe the hit rate and miss rate here. Also show what instruction is missed and hit. So that's all from me. Thank you.
For discussion, our proposed project is to improve and determine the which case is enhanced direct map cache performance, whether it can cause hit rate or miss rate due to the performance. We can analyze that from case 1, hit rate is 33%, while miss rate is 67%. So that means processor has go to main memory to fetch the data and the process is miss rate. Next, in case 2, we got hit rate is 53% and miss rate is 47%. So from this we can analyze the data process has been improved than case 1, especially to fetch the data and it called hit rate. The calculation of hit rate and miss rate can be applied in this project due to the theory that we have been studied. For conclusion, throughout this study, it will be found that enhancing direct map performance by reducing the miss rate by changing cache parameter that can affect one or more cache, and we can increase the block size to reduce the compulsory miss. To increase hit rate percentage to make cache performance or transfer data will work faster, this will be solved by using Paracache software. The solution is economically viable due to its simple and inexpensive to implement. By using Paracache as a method proposed, seems to have a fine solution for these problems. In addition, the Paracache work on the request address is broken down into index, tag, and offset. Next, cache table with appropriate index will be checked. Cache miss is obtained when the index valid bit is equal to 0. In cache table, the else tag will be compared to tag bit. Cache bit will be obtained if tag is matched, and else cache miss obtained. Yet, then cache hit is obtained, it will return the data from the table, else data will be taken from the main memory. Throughout all this project, we can calculate manually hit rate and miss rate. By using Parakeet Simulator, we are able to calculate the offset, index bit, instruction line, tag, and blocks. We can also construct the instruction needed to make an output. We can analyze the case from 1, hit rate is 31% while miss rate is 69%. So that means Processor has to go to main memory to fetch the data and the process in miss rate.
Okay, for the Q&A question, based on the first question is what is the unique features of our project is our project is about enhancing direct mapped cache performance, which is about how we improve the performance of the system by improve the cache performance. So here we see that we must get the hit rate more than the miss rate. Therefore, the unique features that we have applied is we change the cache memory size, and then we observe the result whether it is hit rate or the miss rate.
Hi, I will answer the second question, which is the current trend of computer architecture is related with our project, because you can see nowadays the computer technology is growing fast. So what is related with our project is about speed of a processor or computer itself. So as we know, speed in computer is very important because it will affect the whole operation of a computer system, especially in data processing.
Assalamualaikum, my name is Muhammad SYAZWAN NOORDIN, and today I am going to solve question number 3, which is explain on how your project can support the sustainable development. Okay, for the sustainable development or SDG, we more focus to SDG number 4, which is quality education. Our project can be used for education purpose. It is because our project include all the basic direct map, theory and practically. It is because the technique is very simple. Every student or every lecturer can use it for their study purpose. Secondly, the mapping scheme is easy to implement, so they face no problem to use our project. And lastly, our project is likely to be needed in the future. It is because direct map is used to speed CPU. It provides higher speed across for the CPU. That's all from me. Thank you.
Question number 4. Explain the current trend of computer architecture for a sustainable development. The impact of technology, especially the digital one, can be clearly noticed since the computer architecture of the 90s. These technologies, which related to the West, are often linked to the concept of globalization, including marketing, capitalism, and commercial culture. Example of the computer architecture technology where the computation capabilities of computer are utilized to boost the building form, making it easy to design complicated organic shapes with no construction documentation constraint.